Welcome to the Introduction of Analytics Systems, Data Collection and Analysis Platform Architecture. This is a system design series that explains analytics systems for beginners. Let's explore the core components of an analytics system. These include data collection, which involves JavaScript tracking, event capture, and user behavior monitoring. And then, real-time processing consists of stream processing, data transformation, and aggregation pipeline. This slide dives into the data collection architecture. Here's an example of a tracking script. Analytics is initialized with a tracking ID, auto-track enabled, and IP address is anonymized. Events like page view are tracked, capturing the page's path name and title. Different data collection methods are used like JavaScript software development kits, server-side application programming interfaces, mobile software development kits, pixel tracking, and webhook integrations. Now let's discuss the data processing pipeline. The first step is ingestion, where data is taken in using technologies like Kafka, Kinesis, or PubSub. Next is processing, which involves transforming and analyzing the data using tools such as Spark, Flink, or Storm. Finally, the processed data is stored in systems like BigQuery, Redshift, or ClickHouse. This slide focuses on event schema design. A standard event format includes fields such as event ID, timestamp, user ID, session ID, event type, and properties. Common event types includes page view, for when a user visits a page, click for when a button or link is clicked, and purchase, for when a transaction is completed. Here is a deep dive into the storage architecture. Hot storage is used for real-time queries, recent data access, and low latency requirements, using technologies like Redis, MemoryDB, and Elasticache. Cold storage is used for historical data, batch processing, and cost-optimized archival, and this is achieved using technologies like S3, Glacier, and BigQuery. Now let's explore the query engine and analytics aspect. Here's an example of an analytics query. It selects the date, event type, event count, and unique user count from the events table, filtering by timestamp and event type, grouping by day and event type, and ordering by day in descending order. To optimize queries, techniques like partitioning for time-based data, indexing for user IDs and timestamps, and caching for pre-computed aggregations. This slide is about scalability patterns. Horizontal scaling distributes the load across multiple nodes, sharding data by user ID or time, which enhances fault tolerance and cost efficiency. Vertical scaling, on the other hand, increases server resources like central processing unit, random access memory, and storage for higher throughput, resulting in simpler architecture and management. Now let's move to privacy and security. Key privacy measures include data anonymization to hash or encrypt personally identifiable information data, Internet Protocol masking to remove the last octet from Internet Protocol addresses, consent management for General Data Protection Regulation and California Consumer Privacy Act compliance, and data retention for automatic data expiration. Here's a data protection example. User data is anonymized by hashing the email and masking the Internet Protocol. General Data Protection Regulation compliance is ensured by checking user consent before tracking events. Finally, let's summarize the key takeaways. For architecture design, consider a distributed pipeline for scale, hot and cold storage strategy, and event-driven data collection. Regarding privacy and performance, ensure General Data Protection Regulation compliance by design, implement query optimization patterns, and adopt a horizontal scaling approach. Thank you. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.